And welcome to the desk of Ladyada.
Hey everybody, welcome to a Tuesday afternoon evening desk of Ladyada.
Also known as the Tuesday Massacre.
I'm gonna kill these boards.
Yeah.
Gonna kill these Gerbers. Yeah, I was just gonna quick check-in. Hopefully no Windows 7 excitement. So I'm just gonna show off this tester that I've been working on.
Yeah. Let's do this.
Yeah.
What do you want to show first?
Well, let's go to the overhead and I can show my circuitry. So, 1 second. I'm really sneezy today. It's like allergy season.
Oh, yeah?
Okay, I'm going to sneeze in like 2 seconds. So, the Circuit Playground boards I have finished up. So this is the final board before the production run. This was a small prototype run. And this is the board I've been working on for a while. It has the SAMD chip, some SPI flash, can run Python, LEDs, 2 buttons, a switch, piezo, accelerometer, capacitive touch, microphone, temperature, and light. So like it's a smorgasbord of sensing and capability for wearables and projects. So this is looking pretty good, and the hardware design is done. Like definitely all the sensors and inputs work. I'm still, getting all of that integrated. So for example, I have the speaker working separately and I have the microphone working separately, but I have to see if I have to add DMA or optimizations to make it work better. But I still want to do a developer's release where I release it and then we can work on the hardware. So tomorrow I'm going to be doing my first production run, and that's when I actually get panels of PCBs. We run them on the machines and we will try to manufacture 200 of these. It's a good number. It's a good number to let me know, what the yield is like, are things working, and then get enough out to people and maybe put some in the store as well, so we can get really fast feedback and people playing around with these. So to do that, I have to design a tester. So historically, what I did for the last, I made 30 of these. I hand tested them. Basically, I programmed them with this jig, but then I uploaded an Arduino sketch and I played tones, and I just listened to the tones and I was like, yes, those tones are correct. Or it displayed rainbow LEDs and I just looked at it. But if you really want to, do a large scale manufacture, you can't just clone me. You can't have me around. You actually have to have as much of it automated as possible. So for example, when I was hand testing, I would use this remote control that I have, and I would actually run a sketch and I would press buttons on the remote and see what the Circuit Playground emitted, but I want to automate that as much as possible.
Okay, can the Feather NRF52 be used with CircuitPython? I know it can run Python, but specifically, can it show up as a USB drive?
It cannot, because I have native USB.
And there you go.
Which this chip does, which is why I really like it. It shows up as a disk drive, and I think it's a killer app. It's worth it to wait for the NRF52840, which does have native USB, so it will be coming out.
I agree.
Soon.
Once you have something show up as a USB drive, and that's how you start to do development, it's really hard to go back.
Yeah. So I just thought I'd take a quick tour showing off this tester. So this SAMD is the 3204 based boards I can test actually using an Arduino SAMD, because I have bitbang code that allows me to program the chip. But the SAMD chip is complicated enough. I actually need a computer to program it. But instead of using a laptop or a desktop computer, I use a Raspberry Pi. And this is actually where I found I made a mistake. So on the back of the board, I have these two pads right here. Those are the SWD pads, SW clock and SW data, and that's what I use to program it. And I forgot while doing the layout, because I've been hand testing, that when you use the J-Link, so I've got like this J-Link. So a J-Link programmer can program these chips without the reset pin. But if you want to use OpenOCD, you do need to have the reset pin exposed. And I forgot because all of the other boards that I've ever developed using this chip always had the reset pin on like a GPIO or something. So like a Feather had it broken out or a Metro had it broken out. So I forgot that. So for this version of the tester, I'm using a J-Link. But what I want to do is update the board. So I only have 200 or so PCBs, and next time I order the PCBs, I'll have a reset pad that I've added, and then I'll be able to program it directly from the Raspberry Pi using OpenOCD, which is really neat. Like the Raspberry Pi has these GPIOs, you can connect it to your chip, and it will program that chip for you without needing like a programming dongle, which means you have one less thing can go wrong or get disconnected or like over voltage or whatever. And it's also very fast because there isn't this like USB interface. It just programs the chip directly. So that's one of the things I learned today or yesterday as I was building this. I was like, oh shoot, I totally forgot to bring out the reset pin. So I'll do that. But one of the neat things about microcontroller programming is that you can have it do its own self-test. So let's go to the computer and I can talk about the self-test a little bit. So the self-test is written in Arduino just because I have all the example code in Arduino already. And so for example, I'm still working on it, but I test the switch by trying to pull up or pull down the pin. And because the switch, it should be pulled low, so even if I have a pull-up on it, it should like not register. So it has two options. It's not a perfect test because in theory the pad could be shorted, but it's actually pretty unlikely for that to occur. It's more likely that the switch isn't soldered in place. And so that's how I test the switch. Although I've never had a problem with this switch. And then the thermistor, I actually just measure the temperature and I just make sure the temperature is between 17 and 40 Celsius. So the reason I have a range is when they come right out of the oven, they're a little hot, and sometimes if they've been in storage, they're a little cold. So I don't look for room temperature. I give myself like plus or minus 10 degrees basically temperature range. For the light sensor, I do a little trick where I do an analog reading, and then I turn on the pull-up on the pad, and it should rise just a couple of counts basically, and that lets me know that the light sensor is there because you have to detect common failures. The most common failure is either the LED is upside down or missing, usually missing. And if it's missing, when you pull up the pin, it should rise all the way to the top rail. So these are little tricks you just learn, like, oh, how do I test this thing? It's like by doing things with pull-ups and pull-downs, you can test whether something is connected to a pin. So I check, what's the light sensor reading without a pull-up, with a pull-up, and then I just make sure that the value is higher with the pull-up, but not too high. For the accelerometer in the middle, that's an easy thing to test. I just try to turn on the accelerometer, and then I measure X, Y, and Z acceleration. And because the tester is flat on the table, I basically make sure that I'm only measuring about 9.8 meters per second going down. So I just say like, okay, it has to be between 12 and 8. It gives me some range in case it's like tilted or somebody's just jittered it or something. And then I make sure, the X and Y are less than 3, so it basically means it's flat. And that tests communication that the accelerometer pretty much works. I also check the interrupt for the accelerometer. So whenever I do a reading, the interrupt fires, I turn that on. And so I have an interrupt pin that tells me when the interrupt state changed. And then I do this thing where I test the pairs of the pins, and this is kind of like a trick that works pretty well. What I do is I connect opposite pins to each other, and then I, basically check that, I can pull it high and pull it low, and the opposite pin responds, but none of the other ones do. So I can show them the overhead really fast. So let me remove this test board. So you can see here, these are connected to each other. So this pin and this pin are connected. And then over here, you can see like this pin and this pin are connected. So that's how I test. You want to have pins that are connected that are not near each other. So it isn't that they're a bridge, that there actually is a connection. And then, so the fun part is a lot of that stuff that I just showed was from the original Circuit Playground. So now what I'm adding is all the extra stuff. So I have to, for example, test infrared, because infrared is one of the new additions that I made. One thing I don't have to test is the capacitive touch, because it's now done completely in hardware. So I don't have to test that part. So I save a little bit of time. Basically, if the pad connections work, I'm good to go. So I skip that. But for IR, I wanted to test receive and transmit. And one thing that I could do is I could bounce a signal off. It actually does, when you transmit, it does read the signal. And I was thinking, maybe doing that. But for now, what I've done is I'm using the Raspberry Pi. It has the ability to do infrared receive and transmit. So for example, right here is an infrared LED that's connected up to the Raspberry Pi. And I use LURC, which is the Linux infrared control protocol. And I installed on the Raspberry Pi, and I basically can send commands. So I can, over here I have a little receiver, and over here I have a transmitter. So I use Python to tell the Raspberry Pi to receive and transmit infrared. So I just have a little thing here where I basically send a message, and then I look for a message, and I make sure that the message is a certain value. And if it is, I say IR OK. And then the last part is I check the buttons. And so this does require human interface, because I guess I could connect a solenoid to the buttons, but that would be kind of weird. So instead what I do is I light up this LED next to the button, and then the tester person presses that button, and then it lights up the other LED, and they press that other button. And then once that's done, all the LEDs turn green, and it prints out test OK. And that message is basically sent from the Circuit Playground to the Raspberry Pi, and then the Raspberry Pi is like, oh, okay, it's time for you to get reprogrammed with the final test sketch, which is here. So I just thought I'd show that off. And that's kind of, and then you have some stuff you want to show off.
Well, yeah, wanted to move the tester out of the way and show off the lunchbox.
Would you want to do that now, or do you want me to test the tester? Show the tester.
Oh no, test the tester.
Yeah, let's just test.
Yeah,
let's
I only have. I'm only going to ask you to show a lunchbox. That's it.
Yeah.
We
So
have
let's
a
go
lunchbox.
to let's go to the computer, and I can show this happening. So for now, I'm using it. I'm controlling it from the command line. I'm SSH'd into my Raspberry Pi, but this will be completely controlled from the buttons on the Raspberry Pi going forward. So the program I have is called CPIM0. And again, normally it waits for like a button or something, but for now, while I'm doing the testing, I manually run it. So to start with, it uses the J-Link to program in the Circuit Playground, and it's a little slow, but that's okay. And then, it's running this test, and this test is actually failing on pin 20 here. It's because there's like one of these pogo pins is a little loose. So it went through, and it tested the switch is okay. It tested the thermistor. It said, okay, the temperature is 25 degrees, so that's good. Thermistor, okay. Light sensor test. The light sensor without a pull-up is 80. With a pull-up, it's 84, so that's good. Light sensor, okay. Accelerometer test. Okay, so it looks for the accelerometer. It finds it. And yeah, the Z is about 9.8 meters per second. Squared X and Y is, less than 1. So the list 3DH is okay. And then it tests the pairs. It tests those opposite pairs of pogo pins, and it finds that they seem okay. Then it is the Raspberry Pi, it makes the Raspberry purple messages, says, okay, it's waiting for the remote message, and then it got a message from the Circuit Playground, and now it's sending a bunch of messages. The first one doesn't actually get read properly by the Circuit Playground, but the second one does. And again, I'm still thinking, like, if this makes sense, like, I might actually just, you know, in the tester, maybe I'll have just something reflective above it, and it will just send the message to itself, because you can, like, the Circuit Playground can do that. It can send and receive at the same time. And then, so it says IR is okay. All right, so now it's waiting for the left button. So then if you go to the overhead, you see that there's this white light. So when you press this, all the LEDs turn red. And then it says, okay, now hit the right button. You hit the right button, all the LEDs turn blue. And then when you're done, they all turn green. And that's when the Circuit Playground now is programmed by the Raspberry Pi to have a blink sketch, which actually failed for some reason. I don't know why.
Tester, oh no. Question.
Yeah.
For the pogo pins, aren't they too big for a pogo pin, the holes for a pogo pin?
The pogo pins are like right next to the holes. They don't go through the holes.
Okay, there you go.
Yeah, you just have to like just nudge them over a little bit. There's enough conductive material. Let me go through this test again.
Could you test two at once facing each other?
No, I think I prefer just to test one board at a time. Okay, so now that it passed test, can you go to the computer real fast, and I'll just show you. So this is when it succeeds, it just prints out, you know, okay, test passed okay, programming blink, it uses the BOSA tool, and then it took 26 seconds. So about 30 seconds is a good amount of time. It's still failing on the BOSA upload sometimes. I'm not 100% sure why. It could be this Circuit Playground, because I'm only testing this one. Like, there could be something loose or bad with it. It could also be something not powered right. I'm not sure. One of the things that's a little... You can design a tester, and usually design a tester with like 3 or 4 boards in mind, but then you really get to tell if the tester is working when you have 200 boards. So tomorrow when we do a production run, I'm going to really get a good feel for the test procedure.
Shout out for 10-digit precision for the timing.
I know. Well, you know, you want to get your nanoseconds right.
It matters. You know, when you add up all those nanoseconds over the course of an entire lifetime of testing, it'll add up to like 4 or 5 seconds.
That's float. I mean, this is what gets returned from the.
Hey, look, it's life.
Timing, Python timing.
At the end of my life, I'll be begging for a couple nanoseconds.
You want those extra nanoseconds? Yeah. 32. So that's that. So I do have to test still the microphone and the speaker, but today I was basically playing around with the IR stuff, so that was kind of good.
All right, let's go back to the overhead. We're pleased to show we have a lunchbox coming out. Ladyada, show the lunchbox.
Okay, so how do you want to do this?
I don't know. I mean, hold it up in front of the camera.
Oh,
Here,
yeah.
I'll get you on the, here you go. Look at that. That's a lunchbox. With Adafruit.
It looks way better than I'm going to show you.
Yeah, well, that's what I thought I
Yeah.
was going to give you a break. So you tell me when to go to that one.
Yeah, go to this one. So it's metallic and shimmery. So this is like a shiny silver, and this is like a metallic blue.
Yeah, it's beautiful.
And this is the lunchbox.
Yeah.
So this is our first sample, and then you can...
Oh, while you're showing off, here's some questions.
Cool.
Someone wants to learn C++ programming for microcontrollers. What would be a good resource?
Dude, if you want to learn C++, Arduino's the way to go, because it's all C++.
Okay. Yep, these lunchboxes will be in our store. We're also going to have them as part of packs, and we're also trying to work with some companies so kids could have packs of electronics in lunchboxes and have a lunchbox as well.
This is like super cute because it's perfect for storing all your parts.
Mm-hmm.
Anti-static, Faraday, nice and durable. They're really nice lunchboxes. The embossing is like super sweet.
Mm-hmm.
Yeah.
Okay, everybody. That's it.
That's what I got. So I'm going to finish this tester tomorrow. Maybe you'll do some live from the factory.
I might try, yeah.
Because you've been playing around with some things.
Yes, that's right.
I have seen things, people.
I might.
I've seen some things that you would not believe.
Yeah.
But we'll be manufacturing Circuit Playground Expresses, and with any luck, they'll be in the shop either late this week or mid next week, early mid next week, because
Yep.
I wanted to get them out before Acre Fair, so they'll at least be in the store. We'll only probably have about like 100-ish in the shop, with a like limit of only a couple per person, just to keep it from. I don't want like a reseller to come in and buy 50. It's not ready for that. But we'll have them for people to play around with. It'll be developer edition, but
For the folks who are
developer
in
edition.
the chats frequently and promise to do a project, maybe we can give away some. We have the payphone we're hooking back up, so we'll figure it out.
Yeah, we'll definitely be able to give them away. Like right now, I did make, the 30 that I made. They've been going to partners. Actually, you know what? Do you want to just like? Do we have like a few? No, we're 20 minutes.
We need to.
We have to go.
Yeah.
But maybe next time I'll show MakeCode, because the people at Microsoft have been doing a lot of really cool stuff with MakeCode to add support. So they've been getting all the extra Circuit Playgrounds I have. But
Someone wants to know what's underneath the shielding of the Easy Link. I guess what's Easy Link?
the shielding of the Easy Link.
Okay. All right, we'll see everybody on
I
Show
don't
and Tell
see
tomorrow, 7:30
Okay.
p.m. Eastern Time, and then Ask an Engineer at 8 p.m. We'll be announcing this soon. Pi Maroni is going to be on Ask an Engineer next week. Big deal. And thank you, everyone out there in the community. The world's on fire, but there's no better place and no better group of people we would rather spend it with from now and forever than all the folks who hang out. So thank you. I'm staying off on Twitter in the news.
Yeah, totally stay off Twitter.
Yeah, it's not fun. Okay.
All right, I'm going to finish this tester so that we can manufacture more. I'm super excited. I still owe the viewers a last stream about
Yep.
PDM microphones. I took a break because I had to just get all this other stuff going, but that's the last piece. Also, a lot of DMA is happening.
Yeah.
We are, and one fun thing is we can play WAV files that are stored on the SPI flash. So that's going to be a super fun thing, and we've had a lot of ideas for other terribly adorable projects that we could do with Circuit Playground, thanks to the analog output and DMA and fast speed of this chip. All sorts of fun stuff.
Okay.
TV be gones for everyone.
All right. Thank you, everybody.
Bye, everybody.
Here's some music. You're on the cover of Make. 11 years.
Beep boop, boop beep beep beep.